Alright, we are now live an hour after I said that I would go live. Now, the question is, this time, and the reason it took so long for me to set up is we are attempting to multi-stream. So I should now be live on both Twitch and YouTube, and I should have a chat window that shows chats from both of them. Which I want to test real fast. So let's see if the YouTube chat works. Doesn't seem like it is. And looks like I'm dropping frames. I'm just gonna turn down bitrate slightly. Okay, that seems to have stabilized it. Let's see, let's check how Twitch is doing. Here we go. So Twitch is showing up. Get some music on. All right. So we have that working. Only thing is I don't see YouTube chat showing up on the Stream Elements thing. Let's see, I thought I had this linked to both of my things. Oh well, I guess no combined chat window. For now, it's only going to be Twitch chat. Oh, hello there. How's it going? Give me a second while I set up chat, because we are attempting to multi-stream at the same time. So we have multiple chat windows for me to look at. There we go. Live but unstable. Well, I mean, since when has Twitch been stable? Alright. Back to actual coding things. So today, what the plan is to actually implement Boolean values. So when we left off last stream, we actually had where we could just put in Boolean constants and it would just work that way with Boolean constants. So see, if we have it as true, it returns 7, which is the result of this equation. If we put in false, it returns 32, which is what you'd expect it to do, because if and return. Now, the thing is, that isn't very useful. We have all the assembly actually laid out, so it's we can now add more functionality to that. And what we're going to try to do is create a condition. So the hard part about this is that the way that conditions work in assembly is you don't pass in two registers and get the result as just another register. Instead, it sets, you do a comparison operation or a math equation. You actually don't need to do an actual comparison command in assembly. You can actually just take the results of previous math equations because those set flags as well. So it's like either or. So for example, if I was doing a minus b, it would be able to, well, really it would be a minus b equals 0. One way that this could be simplified is just, you don't actually need to check the condition, it'd be a double, but you don't need to check the condition, it would just basically do the operation and then check flags in the register. However, I'm not going to put in the work to do that quite yet. What we are going to do is just have it so we can convert comparison operations when we need to. So for example, here, we're going to say A is larger than B. And then I'm just going to return 1 or 2. 1 for A, 2 for B, basically. And I think I've already implemented comments, so I should be able to actually mark this up. Yes, I have. So I can go and this as well. So then after we do all of this, we'll be able to just test the function. Now, the question is, how are we going to convert this into a Boolean? My plan for this is to extend the value index, and I've already gotten started on this. So I have a set of flags, which realistically could be an enumerator, but right now it's just, I feel like in the future I could have other flags as well that could apply to more than just one type of value index. So for now I'm keeping them flags. In the future I might change this to an enumerator because it would be like one assembly instruction faster on the end. Then again, actually, let me look this up. So ASM add, not add. Here, let me pull this over here. I wonder, do assembly language, not BitShift, what am I thinking of? And op. Does this set the flags? I have to Google this correctly. Because if it doesn't, our flag set when the AND operation in 86 is done. Flags will be affected. Okay, so it's comparing these flags is not actually an actual, it's not an extra assembly instruction. The compiler would be able to compare it just as fast as a regular enumerator. So I don't actually need to worry about that. All right, but anyway, back to what I was getting to. We now have an extra flag to represent that this is not in fact an actual memory or register value. It is a comparison result. So we'll be able to use this to be able to tell from an if statement, is this value that was passed to us an actual Boolean that we need to test, or is it just the result of a comparison? Because if it's the result of the comparison, we can just skip the comparison result and go straight to a jump if not 0, for example. Otherwise, we would need to cast it or compare it. Yeah. So let's get started on this. So operation nodes, the first thing we're going to need to do is add in this comparison node, which we're going to have be a dual argument node, which means I don't need to add anything. Let's just get started on implementing it. And then I think I also need to add an enumerator value to here for a comparison. Output variable, an empty variable of the return type that is automatically the variable returned if nothing else is specified. So if you want an output vector, instead of creating a new variable, you could just push back output, which you didn't declare. That's interesting. So you're saying that instead of so let's just say we have an example function here, which is int foo with the argument bar. There would just be an implied out variable, which would be of the type that had been requested, essentially. I'm thinking about what other things, what could go wrong with that. It depends on how it was implemented. Well, actually, with how I'm making it, the only thing that would cause real problems with that would be returning objects. And if we wanted to initialize an object, since the way that I want to, let's see, the biggest downside is a small loss of memory. Yeah. Yeah, the only instance I can think of where this would be a really big problem, because if you return from the function, you're going to have to allocate it eventually. The only thing I'm thinking about is structures, and because the way that I want to implement those is basically, it'd be kind of like how C# works, where they're all created on the stack, and I would use like the sort of, well, not the stack, the heap. Basically, they would all be stored by references. So not like raw pointers, but instead indexed things. But then again, we could just have a null reference as that output, and then somewhere in the function we would need to allocate something and send it to there. So it wouldn't be like defaultly allocated. It would be just the container would be there for you to put it in there once it was done, or reference. So I actually think that would work, and it wouldn't be too hard to implement. We would just like reserve out as like a reserved word of sorts. That's actually a pretty cool idea. I don't know of any other programming language that does that. Mostly because I feel like people would want to kind of want to be able to specify it manually, but I don't really see a problem with that. And especially because that would make sure that functions always have a return value, because you always have an object that has already been allocated to be returned with assumedly a default value. And then it's just you would call return, and then it would return whatever's in that value, and then there'd just be an automatic return at the end of all functions. So that could get rid of a very specific error, I guess. Yeah. I would be fine with you trying to implement that. If I don't get to it myself first. But for now, we are working on Booleans. So I'm going to continue working on that and delete that function. But that is a really cool idea. I like that. Result type. Well, actually, it would be Boolean. What did I name it? We're gonna change this to native type def. And then what would happen in here is we'll just leave the default optimize for now. Then we're going to return, well, nothing yet. Don't need to create a new register. Flags, and we're just gonna set this to actually no, this is the wrong place to do that. Value index flags. And then this would be comparison result. And that would basically be it. Yeah. Def. Context. Actually, no, this would be. And here's where we would append the code. So let's create an enumerator for all the types of comparisons. I'm just gonna call this compare. Gonna have equal, greater, equal, greater, and greater equal just for now. So just numerical comparisons. Yep, that's basically it. We just need switching. That's exactly what I was thinking. And what really confuses me is there is assembly instructions for, you know, less than and less than equal. And I'm wondering if behind the scenes, like, it's really weird that assembly language of all things would have a usability thing like that. So I'm wondering, is there some like extreme optimization strategy where you're like shaving off fractions of a nanosecond for not having to put one register in a, like, swap the registers that it's using? I doubt it though, because that wouldn't make much sense. So I'm just kind of like, I feel like behind the scenes, this is how it would be done anyway. Oh, we're getting into the has to be declared before. Beautiful. Yeah. it worked. It's always nice when the compiler things to help you out work. Append code. Script. And this is going to be a... Wait a second. It would just be compare. So I don't need all of these. The Zol. I'm going to create a new type definition for comparison results. That way yeah. I feel like that's the best way to do it. And then just have that store the type of comparison that was intended to be done. Since comparison is just a single command and it sets all of the flags all at once. That's the thing that immediately jumps to mind, because my idea is that I can just pass this value off, and then if something needs it as a Boolean, it can then cast it to a Boolean. Or it can just say, oh, there was a comparison done. So yeah. Okay, it's not complaining. So this is just like a hidden unknown type. Here, I want to check something real fast. Okay. I was just checking real fast to see if my Twitch stream was actually streaming. Alright, back to this. No more getting distracted. name, we're actually going to return null pointer to kind of tell the compiler that this is not an actual value. It's just a comparison. Well, actually, storing it in the actual thing would require different instances of them, so I'd have like a bunch of different definitions for each. No, this isn't. No, I don't think it is the way. So how am I going to represent this? I'm gonna bring out Notepad for this. So for now, I have 3 scenarios. Well, actually, really only 2. So I have Boolean. Which is equal to a condition. And then with a implied cast here to bool. We also have, that's actually one of the reasons I'm making it. The language itself, I don't think will have a threading system built in, but calls to it will be thread safe, if that makes sense. Another reason I wasn't using Lua is because I realized that to be able to make multi-threaded calls to the same function in Lua, I would have to make a entirely different script context for every single thread, load up the entire script onto every single one of those, and then send one of those off to each one of those threads, and I'm just like, no. So, but since this just compiles to a C function, it would be just as thread safe as a C function. So, if say you extend it with some C++ code, and that code itself is also thread safe, then it would all be thread safe. So, if you were calling this function here that you extract from the script from multiple threads, you wouldn't have any issues. So thread safe means that you won't have race conditions. So let's say that the script let's say you have a function and it's accessing something like a list or a integer, and both of these functions, I guess it would be the same function in this case, but you have 2 threads running the same function and both of them act on the same variable. If 2 cores are slightly out of sync, they might try to write to the variable at the same time, or one might check it and then do an operation, and then by the time it gets back to the variable, it's like out of date. So there's like a lot of really weird edge cases that can be created by that. And the way you get around that is with thread safe objects like mutexes. So a mutex is kind of like almost like an airlock of sorts. I'm trying to come up with a better definition. But basically, one thread will have to request access. The mutex goes, all right, you now have access to this variable, and then it will do whatever it wants to, and then it will tell the mutex, okay, now I'm done. And then any other function that wants to access that mutex at the same time will have to wait until that first thread lets go of it. So regularly code does not care about that. It will just zoom through all its operations, because to be honest, it doesn't need to check most of the time. In fact, most programs are primarily single-threaded. But anytime you have multi-threaded code, anything that could be accessed from multiple threads at once, you need to make sure that race conditions don't occur. Yeah. That's kind of the TLDR of it. I'm going to change this to not flags, and then we'll be able to set a different type for every single... Yeah, that's going to be a much better solution. So we're going to say value index or just value storage type. And then I'm gonna actually have registers be default. So on a scale of machine code to JavaScript, somewhere right in between C# and C with a little bit of Rust added in. So lower level, but not like C++ low level, if that makes sense. Going to be 0, 1, and then we can just do numbers. So now we have 200 some options instead of just 8. This will have to work for now. And I might come up with something better before, or better later, because this doesn't need to be sent to the client. Or, yeah, the interpreter. But right now it will be sent. But then again, we'll never send any with this, because we'll always cast it and not send it directly. Well, we'll see. It will probably be like 3 a.m. tonight. I'll just be lying in bed trying to sleep, and then the solution will come to me. That's usually what happens. Where was I going to go? Alright, I was going to fix everything that uses flags. So basically anything... storage type. So now a bunch of stuff is gonna show up as not showing up. Wait, why did I set all these as 2? That's a catastrophe waiting to happen. So back to the comparison. Which is here. And I'm actually going to set these to be equal to the other thing. So value, storage type, equal result. And now when we go into here, storage type, we'll just directly set it equal to mode, because it should be able to, nope, it does not automatically cast. And now we don't need to worry about this switch statement anymore. We can just say, hey, compare, and we are actually going to now actually do generate bytecode. So auto A is arg A, generate bytecode. And I'm going to check real fast if assembly language requires both sides to be registers, or if we only need the left side to be register. So 86 backend compiler. From base emitter. Okay. CMP. General purpose. Memories. Immediate values. Okay, so we can compare general purpose and memories. And then compare immediate also does allow memory. Okay, so we only need to cast A as a register. gonna put that up there because I don't trust the window I have open. All right. So cast register. I'll worry more about this later. For now, let's just get something working and then we can edit the working version. So we now have a comparison operation between these two. We then send back the results. What we need to do next is figure out how to cast the register. So if this value storage type is already equal to value storage type register, then we can return. If this is equal to a memory. Just gonna throw this here. And then for now, the only other things we have are comparison results. So we'll just put this in here. So next thing, how to cast from a comparison result to a Boolean. So you actually won't need to. The way that I'm building the actually building the entire scripting language is that you'll be able to pass in pointers, which will then get you'll be able to pass in pointers to native C types into the scripting language, and then call the methods on those types. All you have to do is provide the runtime with a definition of that type at runtime. So if you created on the C++ side a neural network data type, for instance, and then passed that to the scripting language, you'd be able to call any functions on that just normally as you usually would, and it would be, it'd make the call back to C++ and it'd go as fast as C++ usually does. And then I also want to put in just raw static function calls to libraries and whatnot. So you'd be able to define a library namespace, and then call functions from that library as well. So it'd be like a global object almost. So you won't need to natively add it to the language, because you can just add it to the language within your own program, if that makes sense. And that's actually one of the main reasons I'm making the program, is so that you can at runtime add whatever types you want to, and the idea is to make it as simple as possible to add in those C++ native objects, and then just have the scripts be able to just link to them at runtime. The main purpose of the coding language or scripting language isn't that it's its own environment that you can do everything in. It's more so its purpose is to extend existing C++ programs, where it's something like a game engine where anything you'd want to do is already included in the game engine itself, so you can just call the functions that the game engine has provided to the scripting language, and then it's just able to call those. So yeah, I'm just kind of rattling on at this point, but yeah. So there wouldn't be a specific naming style. However, it would be the same thing where variables would need to start with any sort of letter or an underscore. If it were to start with a number, the language would just assume that it is a number, just because it's really hard to make a syntax where you would be able to detect if it's a number or a variable name. So whichever naming convention you want, just not with numbers at the beginning. Where was I? Oh, right, casting. Right. Do I have a... I do. So, assembly language... So we have zero flag, sign flag, carry flag, and overflow flag. So wait, to cast Booleans, would I have to do a jump comparison? No, wait. There would be like move. So this is what we want, because we can make a conditional move statement, or actually two conditional move statements, where depending on the results of the comparison operation, we could either move 1 or 0 into a register. Okay. Let's add these in. So we have move equal. We have move not equal. We have move greater. And we also have move greater equal. The descriptions on these aren't really accurate anymore since I made it so it kind of auto-detects type. But if equal if not equal. Oh, sorry, I had the chats underneath here. Key files now and use if statements as toggleable comments. What do you mean toggleable comments? It's like you don't have to mess with registers and stuff. Well, see, since I'm just in time compiling it, I have to mess with registers. There's not really a way around it. Don't worry about it. It was my bad for not looking. Let's see. Just value. Oh, wait. There we go. Now it's accurate again. If greater, if it's kind of funny because eventually I'm gonna make like a recap video on all these streams, and I'm proud of myself. I've been keeping track of like how I've been doing things in the actual process. So the next video that's coming out, and I actually have it like planned out. I'm actually going to be releasing consistently on different days and whatnot. Well, not on different days, on the same day, at the same time. So my idea right now is Fridays 4 o'clock my time. So it's kind of like an evening going into the weekend sort of thing. But so the video that I've already filmed about kind of announcing that I'm working on a scripting language will be coming out Friday at 4. And it honestly, it's going to, at least in my opinion, it's probably going to be a little bit boring because it's really just me kind of talking about intentions and kind of just what I want the scripting language to accomplish. But in the future, what I want to do and what I've been working on is doing more of like a storytelling thing where I actually, this is what I wanted to do, but ran into this problem, so did this instead. So I've kind of been keeping track of the process of coding this as I go. So eventually there will be a recap of all. Where was I going with this? And I think I was just gonna say, like, eventually I will have like a recap video of all these streams, and it will actually be enjoyable to watch for the audience. Oh yeah, that's what I was gonna say. It's basically going to be a lesson in assembly code, because I'm gonna talk about, I had to figure out how to convert from comparison operation, setting stuff in flags, to Booleans, and then come up with an interesting way to explain that. And Alex can do fun stuff with like graphics and whatnot, explaining all of it. It's going to be a very fun video to make, because it's going to be the first one that, at least in my opinion, will actually be fun to watch. And that will be coming out in 2 weeks from Friday, since I'm actually going to be keeping a schedule, or I will actually be keeping a schedule. But yeah, let's continue on with this. So in compiler, what we want to do is when we cast register, we are gonna switch on val. Oh, we could have just done a switch. So value index storage type. I'm gonna convert all of this to a switch statement now. Value type register. Case. Value type mem. And then I'll let it automatically create the rest for me. And we can delete all of this. So if this is an equal result, what we'll want to do is let me just check to make sure I'm only calling cast register when I'm generating bytecode. So generate bytecode. Okay, so I am only using this in generate bytecode, which means I can just throw this into there. New register. Okay, so I did do one where you can just pass in type. I'm gonna want to do that instead, because that's a lot more efficient. And it will actually be able to handle null pointers now, which I wanted to be able to do. Storage type, memory. There we go. So now that's all fixed. So now whenever we are creating a new type, we can just put reg value out here. Actually, we still need to have this. Now this can just be we have our new temp value. Now we don't need to create this in here. We can just say code. So this is equal reg. So we're going to So how I'm going to do this is, since it will have to run either one of the equations regardless, what I'm going to do is just have this. And then compiler context. I'm going to create a set function, because right now whenever I set the function pointer right here, I just do it manually, but what I want to do is to be able to append new bytecode to this. So function is equal to that function, but also we can append code and we're just going to create two constants. And these constants are going to be for Booleans. So new constant Boolean with the flags AOT value, constant expression, and AOT value constant. And then we're going to just create AOT value array of 2 Boolean constants. And then when we create new functions, we'll just say bool constants 0 is equal to new constant and then we can just append code script function load constant false. And then, wait. No, first I have to, there we go. Now at the start of every function, we will load in, or, well, it isn't necessarily loading because this is a compile time thing. But we will define Boolean constants. So now up here, when we're casting register, we can append code move constant bool constants 0. So it just resets the register regardless. And then move if equal bool constants 1. And then we will return value. And we can do this exact same thing for greater, but we just move if greater. And here we can move if greater equal. And this should cast the result of comparisons into actual Boolean constants. So now let's make this work in assignment nodes first. So right here underneath cast node, I'm going to create a new class because I already have the syntax for assigning variables, but I haven't actually implemented it yet. So AOT assign node, public AOT dual argument node, public explicit AOT assign node. Actually, since it's not a single arg node, we don't need to have explicit here. So AOT node pointer. We have our left value, or non-constant value, or non-temporary value. AOT node, our value. If we're going by kind of pre-existing compiler notions, we can keep the regular optimize statement, and we're going to have our own generate bytecode. So AOT assign node. This is a dual arg node with L value and R value. And this is of type assign. Oh, that's right. I think I put the type at the beginning. I think. Oh, no, wait, right. I have to put in the return type. or the type definition of the return type. So type def value. Alright, see you around. Thanks for sticking around as long as you did. Type. And also thank you for coming to so many streams. It means more than you think. So now you can just generate bytecode, and this is going to be super simple. Come on, IDE, work with me here. Alright, fine. I'll do it myself. So L value is going to be equal to a generate bytecode and then we're going to return L value. So it'll essentially work like in other languages where after you assign something, you get a reference to it. And then we can just say cast register R value. So now we just do context function append code move L value dot value index R value dot value index, just like that. And that should be all I need to do there, I think. So now all that's left is actually adding this to the compiler and then the script runtime. So visit assignment. There we go. Oh, nope. There we go. We have the node being set. Oh, no, I don't want to do this already. What we want to do is return the correct node type. So new AOT assign node with L value, R value. And it'd be the left value return type. Actually, I can just infer that. So we don't need to pass this in. We can figure it out ourselves. All right, let's add in a compare node. So let's see, we have comparison, which is equal, not equal, or greater than, or well, less than, greater than. less than equal well, greater than or equal to. So those are all our main comparison nodes. So let's, well, comparison types. So let us generate that. Go to Brane Visitor. Visit, where is it? Comparison. Let's just copy this function definition over to compiler. And this is going to return a new and then we're just gonna copy this so it makes it easy. Left, context right. And then finally, AOT compare node mode. We're going to set this to equal by default. And then we're also going to symbol is equal to context operation get text. If the symbol is equal to less than, actually let's do all of the other ones first. Mode is going to be equal to AOT mode greater if symbol equals greater equal mode is going to be greater equal. If symbol is equal to double equals, mode is going to be equal to AOT compare node mode. Actually, oh, it's on scope, so I could just have been doing this the entire time. And now we're going to repeat this for, and I know I don't have a not equal to put in there quite yet, but we will add it later. So if symbol is less than or less than equal, what we're actually going to do is just pull a swap on A and B. Just like that. And let's add in a not equal here. So we now have a not equal. And then let's just make sure it'd be cast register we'd need to worry about. And then we can just swap these for now. Remove 1. If they're equal, move 0. So So now I have to create an entire add operation for each one of those. Well, actually not an add, it's a move. to assert that this is a register. And we're just going to create watered down versions of move operations. So move equal, and that's the only one we need to worry about for now is move move. It is a singular move, which I find funny. All right. So move equal. And we're not going to include any casting, since we want to do that just with the regular move command. So we only need these four. XMM move. Okay, so actually I don't need to worry about conditional moves for XMM registers yet, so I'm not going to. See, move equal. And then we're also going to create another one of these for move not equal, because why not? And then which other ones am I relying on? So we have the conditional moves. Are the conditional moves the only new things I added in? Script functions, move equal, not equal, greater and greater equal. So I need to do greater and greater equal as well. Move G, greater, move greater, move greater equal. Any G G E. Okay. So we have all the conditional moves that we need. Let's see if this compiles. So we were unable to find the identifier for null. It's because I have not defined it yet. So that's on me. Actually, no, it's not on me. Let's throw this into the parse debugger. So we have a declaration. Well, that's in the argument list. Do we have another declaration? So we have a comparison right here, an assignment. So we have an ID and an assignment. Okay. We want definitions to precede assignments. So I think that's all I need to do. No, it is not all I need to do. Can I say expression or declaration here and it won't complain? Because I feel like it might complain about like vagueness since declarations also can be an expression. Ambiguity, yep. But if I just do this, get ID, ID. ID is equal to comparison, Boolean. This is a problem with my grammar file. I'm gonna just go to calling this program element instead of statement. And then we have expressions, but we also have statements. And this statement can be declaration, an assignment, a return value. That doesn't. Don't feel like that would fix the problem either. How do I make it value this over this? Wait a second. I just had an epiphany, I think. Can I do expression returns AOT node pointer? Like that? So would I be able to say just like that? No, it's not letting me do that. Oh wait, I could just do that. And now if I generate that, does it set the type instead of using standard any? It does not. Oh well, I'll play around with that more later. Right now, options. We're just gonna do that for now. If we declare a sign, see, that works. But that doesn't. Oh, wait a second. I know what it is. It's because I have ID before declaration, so ID takes precedence over declaration. Means I don't need a declaration assignment. It should now work. Yep. There we go. It was just that I was dumb. So if I generate this now... Oh. Now if I generate this... Yeah. And run it again, we should actually define the variable before assigning it. I have problem. Found the problem. So we visit the destination. Declaration. What we're going to do is actually no, this would be register local value. Get text, and then we'd also need to get the type. Then we would just return new node. Unknown OP code. Unknown op code. Let's see, I want to go to debug, debugger, hush, 0. Also need to cast this to void. Go, nothing. See this. Script operand. Go in here in this error. Operator or operation. And then OP is compare. Oh, did I never define compare? I have compare 0, but not. That's funny. I shouldn't even need to compare 0 anymore, to be honest. Let's just turn this into a regular compare and then optimize out compare 0. So we have compare. B. There we go. So now we're just going to do that. Go just like that, and let's also scope this. I don't need this anymore. what did I have here before? Unsigned, no, unordered compare SS, okay. Com SS. And then for memory, we'll just copy this as well. There we go. And then script function will delete compare 0 because where we usually call that we can just call compare value index bool constants 0. And float, and for comparing both. Okay. So comparison node. Let me just check to see if there is things for comparing. Okay, so for comparisons, there will have to be automatic casting. So for operation nodes, so this will have to be A is equal to don't have a cast in here. So does that mean that my AOT const is the only one doing casts? No, because other operations are doing automatic casting as well. So add node. Oh, that's right, cast nodes. So I would need to do this up here. Not in the assign node. Well, actually, the assign node should have automatic casting as well. And we also want to automatically cast for assign nodes as well. But we only want to cast argument B. So now the comparison node should no longer have that problem since it will automatically cast. There we go. Now what is the problem? Oh, yep. That would do it. Find this. We don't want to and these, we want to equal them. I overlooked a lot of these, didn't I? Okay, let's see if that fixes it. So in verify value, if index does not equal register size, index is 3, register size is 2. And we are creating this on a move instruction. Let's force print out everything. So print nothing. So this is the first operation ever. I feel like it has something to do with this. Let's check. The assign node, because I feel like it might be that. Generate the bytecode ahead of time. We move left into right. So it might be the declaration node. Okay, let's run this again, generate the assertion. Okay, source is an int 32. With the index 1. Destination is index 3. Interesting. Which means 2 is being consumed by, I'm guessing, the AOT value node. Oh, hey. Let's see. How long ago did you send that? Are you still around? I haven't been looking at Twitch chat recently, so I don't know if I missed you. Oh, yeah. You are still around. Hello. But yeah. I have a good chunk of... Well, this is a scripting language I'm working on for the engine. Right now I'm just working on getting conditions working. Well, I already have conditions working, like if I put in just true or false there, it would work. But right now what I'm working on is comparisons. Though right now the problem seems to be with this assignment, since I haven't tested variable assignments yet either, and I'm still working on those. But yeah, just kind of working on it one step at a time. But yeah, I wasn't keeping an eye on Twitch chat, so sorry if I ignored you for a bit. What was I doing? All right. Let me throw the assertion again to... Here we go. Right, so I think what's happening here has something to do with value nodes. So the problem is probably here. Yeah. Lots of core stuff, just getting the basic stuff working. Honestly, it hasn't been that hard at all. And I feel like in a couple of weeks I'll have a completely functional working thing if stuff keeps moving at the same pace. So this is, yep, it's the assignment node. Where, oh, wait. I think I just got it. So the problem, there we go, it should work now. Because I was bringing the variable into existence before it was ever used, and then the index was, yeah. So now we go straight up to index 4. I don't know where this is happening. Yeah, I made sure that I have like a good framework set up for optimizing, like addition and subtraction. I've already set that up so like constants kind of pre-calculate, but that's all I'm doing for now until I can actually have more put together. But like I've set it up so I can have flags for like constant expressions and all of that sort of stuff. Though with how I have it built out, I don't think I need flags for constant expressions, since it starts at the tip of the tree and kind of just trims down. So the way you would be able to tell if something's a constant expression is just, is it a constant? It'll be more useful for trying to pre-call functions, I think. But yeah. Where was I? What was I doing? Right. Indexes being created out of order. Or registers being registered out of order. So let's do this. So we have, oh, my music just ended. Let me set something else up. It's a lot of horror synth coming up in my recommendations. There we go. Let's do some cyberpunk synthwave fight mix. That sounds good. What I was going to do is, oh wait, it's in the compiler. Value index. This is what I want to check out. So this is what we want to do. So every time we register a local value, we increment the value index as we should. And then whenever we create, well, value index is purely stuff. Wait a second. I just had an epiphany, or realization. So because of how the tree works, when I add value nodes to the tree, I create copies of them. So every time I reference one, I would create a new value index, I think. No, L values, because this is what would take care of that, so copying doesn't matter. Create a new register, context. The value index of this is 2. Next time we visit it, it's only used once, right? Well, actually, we only create it once. So as long as we create it at the proper time. Let me check the compiler again. We need to check declaration. So So we declare, and then on assignment, visit assignment. There it is. Okay, yeah. This was actually the one I needed to swap. I had the right idea. I just didn't do it on the correct node. Which one was the one that I swapped? Left, right, left, right. Because now I need to swap that back or it's broken. Let's see, find A. Ah, it was the, no, it wasn't the comparison. Oh, it was assignment that I did. No, wait, the assignment was the one that I wanted to do the right and then the left. Right and then left. That's the one I just fixed. You don't want to fix it back, because fixing it back means it's broken. Where is it? Where was the one I broke? Where was the one I broke? Left, right, right, left, that is, yep. Well, I don't know what I broke, where I broke it, but I know I broke something. So we're back to 3 being the broken one. No, wait. Now it's 4 being the broken one, which means I fixed one. And we're back to a broken one. Wait a second. It'd be in operation. It'd be in the operation nodes. Because the, yeah. So on the assign node, we want to generate the right before the left. Then the comparison node was the only other one I generated. I'm just now realizing that the syntax tree had nothing to do with that. So which one is creating 4? Let's catch it in the act. Compiler, new register. This is where I should have gone from the start. 0, 1, 2, 3. I want to actually have a look at where this is being called from. It's from the value node. Yeah, one of the, like, I guess, cool ideas I had for this is, what if we didn't have an interpreter? What if it was only AOT compiled? Because then that removes a large, or removes a large portion of what I would need to code, and just kind of forces me to AOT it from the beginning. And the way I'm building it, I don't really need an interpreter, so I feel like it would take quite a bit of extra work to also build an interpreter. And this is a problem with just the compiling side, not with the actual running of the code, because it's never getting to the run stage. The problem is with how I decided to allocate registers, where if on the compiler side I request a register that is one pass to the end of the list of already allocated registers, then it allocates a new one. And the term register is used loosely here because the library that I'm using for the assembly code keeps track of those and juggles them for me, so I can basically allocate as many of them as I need without having to worry about the stack. So that's what I mean when I say allocate register. But so the assignment node creates 3. But then it doesn't use it in anything, so it doesn't actually get registered on the compiler side. Actually, it would get used right away here. But we can't. Oh, it's this casting that's causing the problem. I think. Maybe. Possibly. Probably not. Most likely not. This is a different error. This looks like it's a problem of not reading it correctly. Is this the first operation ever? Or this is the oh no, it isn't the first one. So first we cast the int at index 1 and move it into register 2, which is a float, then compare 0. And then we try to move the pointer at index 52,480 into index 3. So that's just straight up don't know what's going on there. Well, actually, I do know what's going on there. It's because I forgot something very important. Where is it? It would be in operation nodes, be in the assign node. Right. Yeah, and see, the thing is that actually wouldn't help in this specific situation. And I think I already said that because, yeah, but I see how it could be useful later on. I just plan to write like a ungodly amount of tests for this. Just stretch gtest to its limit. So L value, R value, cast registered. So this is what's causing our problems here. So when we, well, actually, let's put the breakpoint there. So we go into the comparison node, and this, all right, see you around. Thanks for sticking around. Let's see. So what storage type to this? This is a greater result, so result of a greater operation. And then we try casting this to a register, which when we generate this new register value here, this register would have the faulty index, but it doesn't. Or the faulty index. Yeah, I'll think about it. Yeah, for now I'm just trying to get like proof of concept working and whatnot. I guess I already do have sort of a proof of concept because I've proven that the workflow can work, at least to the point that I have it. Well, I mean, it's broken right now, but I've had it at points where it works. So it would be the next one that breaks. So this is a... So result of a greater, so it should jump to there, which it does. So then that casts it to a Boolean type, or an actual, like the memory for a Boolean. Register we get back from that is at index 3. So that's not the problem. This isn't the problematic code. I was so confident that I had caught it there, though. Well, actually, I should have looked at the output more, because if we print this again, just flush. The problem is with this move right here. With this move. So I'm guessing it has something to do with our if statement, which is the untested code. So we have a comparison, and then I haven't actually done any optimization, so it's just going to compare the Boolean to the condition, which is hopefully what comes out of here. So condition, if we go into here, yep, this is the value, and we just return. Stored value for that, condition index is 4. We then want to cast this to a register. But it already would be, I think it would already be a register? Type register, yep. So it should just return out of here. The condition variables still look fine. So then we compare this value with 0. And if it's false, we jump to the mark. Because the parser doesn't get past here. Maybe it's something wrong with my compiler and the deserialization, or the runtime when we're actually AOTing it. It would be in the compare function, since that's the last function that went. Do we have any? So we do have a break. Just need to figure out where that's coming from. Wait. That's it. That's the problem. It all makes sense now. And let me actually check my other comparison node. Well, the other comparison node looked fine, but let me just check to make sure I didn't make the same mistake on compare. Okay, I didn't. It was only there. It was a serialization error. Different error? Same error. But that was definitely a gaping hole. Same exact error though, which is interesting. Move. Okay, so it would be in the casting. It would be in the serialization stage of casting. I think I just found it. So it'd be in cast register. Yes, this would be it. Look at this. Disgusting. Because these are like compile time values and then they store the runtime values that are actually serialized. So we don't want to serialize the entire thing, just the value index portion of it. So this time, we're actually getting an error from... Okay, yeah, we're actually getting an error from AsmJit itself. Which means we're closer to getting it to actually work. Invalid instructions. So somewhere we are calling something in a way it shouldn't be called. I'm going to take a wild guess and assume that it is compare. Because I think comparison, we actually need to define the actual width of the registers, at least on the integer side. Yeah. Otherwise it doesn't know how big it is and how much to compare. That was not the problem. Let me make sure that I'm setting diagnostic. Okay, so I am setting diagnostic options. Usually you tell me which instruction it is. So that's not it. Let's look at this over here. Here. I think this right here, this code right here, this is a hint. Because this is supposed to be moving a memory value here based on the result of this comparison, basically casting the result of this comparison to a Boolean variable. but for some reason it's treating it as a general purpose register instead of a memory index. So the problem would be in cast reg, as always. Or no. Oh! I just remembered. I forgot something to do something. So up here, I wanted to be able to initialize some variables. So context dot wait, did I not set it public? All right, it's not there. It's what was I thinking? I was thinking something. Oh my, I just realized why it wasn't bugging out. I just realized what's going on. So it's not here that I need to set this. It's over in the compiler, as always. The problem is that I'm never initializing these Boolean constants. I have this set function, which sets the function variable and then initializes two new constants, which are false and true. I'm just gonna do this because I feel like I should. But I never set this, so we never have those constants actually initialized. However, since this is a just native C++ array, they get the default values, which would define them as registers, meaning that we are moving from uninitialized registers, well, at index 0 and index 0. Well, so they would be registered, but it'd be, I think, wait. Yes, the first argument of this function is a float, and we're treating them accidentally, not on purpose, as, so that's what's throwing the error. It's trying to treat a float as an integer because it wasn't initialized. Okay, so we need to go to our visit function. And then when we set the constant contexts function, we use set function instead. And that will initialize our constants. And I just realized that, wait, no. So constant index isn't being set. Why is the constant index not being set? So when we set function, set the function pointer, or set the function to our function object. Index equals memindex plus 1. Yep. I do plan on making these a regular stream. I've actually been streaming pretty consistently on my YouTube for like a couple times. I've had like 3 streams on YouTube, and I've been doing them pretty consistently. And it's just today that I decided to also multi-stream to Twitch at the same time. So an answer, shorter answer, yes. I do plan on doing these streams more regularly. and also making better YouTube content. Like, I've been writing down kind of the journey of coding everything. So after the next video that I put out, which is going to be Friday, I'm going to try to be posting one every 2 weeks. So just in general, I plan to be a lot more consistent. Yeah. I will see you around then. I will also fix this code by then. Oh, it's the same error. It's you know what? You know what? We're let's see. We're doing a static assert here. That is weird. I have been trying to ping in my Discord every single time. I just do like I have like a notifications role. So you could try that out and see if that works, because, well, yeah, it's me manually pinging. And I should have a link to the Discord in the stream, below the stream, if you want to check that out. See, so static assert is same A and AOT node. Don't want to have to import it, but it is for a good cause. Well, actually, no. Template definition, it wouldn't need it. Possibly. Then again, it is a Okay, we're just gonna... Static assert not is same. And static assert not is same. B. That way I just straight up won't compile if I make that mistake ever again, because I've been making that mistake every single time. There we go. So hopefully this is a different error. Yep. So let's see. Cast, compare. Actually uses memory this time. Move 3 to 4. Compare 4 and memory. Jump if equal to mark 0. Alright, see you around. Thanks for sticking around. Load into memory 3, float. Bool 0, 1. Oh, it actually gave me a thing, so... So, conditional move greater into AL byte pointer. I know what the problem is. The problem is that I specified size right after... Okay. I think I know what the problem is here, so move greater. Did I set the size of the... I did not. so the problem isn't here. Value type is equal to bool. And we have destination register, which would just be general purpose. How would I make it general purpose? Small or lower. Time to look at the docs. There we go. So I just need to look at where do I where we need to search for register. Nope. Okay, let's reload this page. There it is. We need the 8-bit low register. So GP B low. And then we move this. Can I do Z extend on this? No, I can't. So I might end up having to change out these for... Well, I don't need to do any sort of casting in conditional moves because I want to cast before doing conditional moves, even if that's a slight slowdown. Basically, I might need to change these from register types to variable types. That way I can account for variable sizes. Which is going to be a big deal later, so... But let's just test if that fixes... Well, no, I'd have to move this to... I'd have to put this on regular move, GP to GP. As well. Oh, wait, never mind. This one goes... where the memory would go. Yeah. And then this is not conditional, so we'll just... And that should be all I need to do for now. And then... Conditional move byte pointer into AL. The AL register. X64. Let me see. I think in my bookmarks I have a thing that documents all the different registers. Yeah, it's right here. So there's A low, which is the one that is trying to move into byte pointer into AL. So it was already trying to do it correctly. Which means I didn't need to do all of that. That's really weird. Invalid instruction. Conditional move, AL byte pointer. Do I need to cast it to a temporary first? No, I would need to cast it to a register first. Why can't I move memory into that? That's really interesting. And I know that when I allocate the register... Wait a second. Case... I haven't been allocating a register for bools? I need to check this. I haven't. Type value type. Oh, this is a float. No worries there. In 32, float 32, float 32, bool. Okay, so for booleans, nothing. We haven't been allocating for booleans. That's why it was bugging out. Do not care about that. Turn value red type. General purpose. Actually, no, if we can just do that, and then new reg. Script runtime. Right. Where's my fancy class? Aha, validate reg. Verify value. I do have bool. New int 8. Okay. But operation type, that was a bug in there, which is interesting. But I don't think it would throw this error, because this is the correct code, I believe. How often is string to type used? In arguments? Alright. I'm gonna define it regardless. Bool. Type ID. K int 8. Wait, maybe it's in load C Boolean new byte. I do byte constant here too, and that's why it's byte pointer. Wait, thinking I might have it. No, it would be hot. No, wait. It would be if you want to. So 16-bit. This entire portion is 64-bit. This is 32-bit. Char-sized parts of the register. Okay. So that is still correct. Instruction. So it's this one right here. So this move is just fine. And then this one throws an error. Let's see. Mark, compare. Where's move? Oh, the jump instruction, and there's move. So general purpose. It's this mem right here. Is there a... Can I just say byte instead of specifically low or high? (16-bit). So I have to say either the low register or the high register. New byte const. What does this return? Does it return? Oh, that's well, yeah. New byte. New int 8. Yeah. What does this return? A general purpose. That doesn't help me out much. Could I say new general purpose byte? But that's the exact same function. Return the general. General purpose byte. New general purpose double. Let's actually run a test. We'll run a test. So if value type is bool low is equal to no, I don't want you to automatically format. Stop it. Stop it. Stop it. Test reg dot is. We'll get if it's a low register or a high register, and I hope I don't have to switch depending on that. But where is move greater here? There it is. So we will test. Is this a low register or a high register? So one there. And also one that is here. So now the question, is this a low or is it high? It is a low. And it is low. Which means neither of these should throw errors. I'm doing everything right. Why is it wrong? Move Z extend. It's move ZX. Okay. What about conditional moves? Can they have Z extend? No, I don't want to move into zeros. So there's move with 0 extend, but how do I conditionally move with 0 extend? Well, apparently none of this matters because it intuits it automatically. About move greater. Can this 0 extend? It cannot. But it is a valid function because they made a definition for it. Conditional move, general purpose map. Yeah. Moves here. Oh, it's not the conditional move this time. It's the move 0 extend. Alright, I guess we can't 0 extend that move. It is not allowed. Doesn't support the low byte of a register? Okay, so the problem is that conditional move doesn't work with anything but 32 bits, I want to say. So, we do have an alternative, which is we want to try out a conditional increment. I think. If there is such thing as a conditional increment. All right. I'm going to do the smart thing and just look up cast a bool. How to set a Boolean variable. Because Booleans don't exist, but I wonder what people's main way to do comparisons is. Convert pair result to bool. So we test, compare. Is the solution literally to use jump instructions? I really don't want to do that. Alright, let's be smart about this. So, realistically, what's going on here is we need to convert a Boolean, a flag being set into a Boolean. So let's say we have our, let's say that we have our 0 flag set. So out of 4 bytes, we have, say this, and we want to set, what we want is this, if that. Conditional moves seemed like such an easy way to get around that. I'm gonna have just a look at all of the conditional instructions just at once. Right after I restart music, because we're gonna be here for like another hour. This is for arm, which won't help us out much. Conditional jumps. Unconditional, conditional. Okay. So this is just conditional jumps or conditional moves. Alright, IBM, don't let me down. How to write conditional assembly elements and functions. This isn't helping. Come on. Just I want a list of conditional things. Maybe this is what I want. That's not really telling me anything. You know what? Let's look at arm, because arm is probably going to be more useful. Conditional instructions. I'm gonna have to learn ARM instructions later if I want this to work on ARM as well, which I do. That's gonna be fun. And set byte. What is conditional set byte? Set byte on condition? That's like exactly what I want. Okay. That's exact. Oh, and it's only one. Perfect. Absolutely perfect. Set above. Okay, I can work with this. I'm still gonna keep the zeros for comparison operations. Where is... We're just adding all sorts of operands. So instead of conditional moves, because I'm not going to use those yet, except for this one specific instance. So instead, we're going to replace them with set byte commands and see if that fixes it. Test the destination operand to 0 or 1 depending on the settings of the status flag. Oh, that's so perfect because it's just one command. Do I have to reset the register though? Feel like I'm gonna have to reset the register. Unless I have a Boolean temporary. Okay, let's look at the documentation in here for... Do I have it all? Okay. Set... Come on, please tell me you got it. Oh. We're not in compiler, we want to be in compiler, and then we're going to extend base emitter and... No, yep. No. Aha! This and that. Control find, set, Z. They do have it. Okay, and it's only a singular byte. Does this set the entire register? It sets the entire register. Oh, this is perfect. Actually, I'm gonna just search real fast. SM does set the... Does it set the entire register? Okay, that's not helping me out. I'm just going to test it out and see if it works, I guess. And see, I mean, I could test if they're equal. I think I might try doing that. Just testing if true is equal to a set 0. How did I not know about these before? That's like perfect. Okay, so I'm actually gonna put them up here. Yeah. Set. Above is unsigned, greater is signed. Okay. So I'm going to want to use greater for now since I don't have anything signed. So for now, we'll just have set equal, set greater equal. So 3 equals r equals 5, 6, 7, 8, 9, 11, 12, 13, 14. Yep. So now set equal, and we'll just delete all of these move functions because we do not need them. Of course, assembly would have something exactly what I need. And index is register. So we want to verify register index. Set if equal. We don't even need this. It's literally just I'm so glad I had that error because it literally made all of my life so much easier. And now in compiler, no, yes. Cast bridge is just, it's so easy. I don't even need to use the constants. So if we are equal, we want to set equal. If this is not equal, we want to set NE. I'll just add that in real fast. And realistically, let's just remove the numbers for now, since we will need to set them for when eventually this is in production code and we can't have the enumerators jumping around on a whim. But for now, we can just remove them. So we can just set not equal. And then back in compiler, we have a set not equal. And then in script function, we want to add in a set not equal. Percentage HU. I'm just gonna copy that. Perfect. Let's print out our variables. Move instruction with invalid operand. Oh, I accidentally forgot to set these to set greater equal. Did it just work? Let's set this to higher. Will it return? Oh, wait. Oh, yeah. Yep, it just... Okay. Now, what if B is larger than A? It doesn't work. It just is always returning 1. What if we swap it around, though? It still returns 1. Let's change this to float and float. Just to remove anything. Could it be a problem with float? Wait. It's probably a problem with float. Because does float set unsigned registers when it compares? Test result 1. Test result 2. Okay, so integers are working. Integers are working. It's actually working. I'm not insane. It's actually working. I might actually be insane because it's working. I probably lost all mental faculties. All right. So the problem is that okay, I have to search documentation again. We're searching more documentation because this is gonna work. This is gonna work by the end of the stream. It's 1:17 a.m., but it's gonna work by the end of the stream. So in script runtime, compare. When we compare two XMM registers, this is where the problem is. We need to check the reference for this operation. Unordered compare scholar single precision. Load over sets the 0 flag and okay. Gotta get the documentation in front of my eyes at the same time. So it sets the 0 flag, what is the P flag? PF flag. So the E flag, okay, we're just gonna use this. The carry flag, okay. We're gonna move this over here, and then we're gonna use this documentation over here. So the ZF, which is the 0 flag, the PF, which is the party flag. I don't know why they're having a party with flags, and the CF, which is the carry flag, okay? Register according to result. Unordered, greater than, less than, or equal. The OF overflow, SF, which is the signed flag, set to 0. Okay, so XMM registers they use signed things. They used unsigned things, and right now I'm using signed instructions to check so it's using unsigned. What if I use comparison ISS? No, I don't want that. ASM. Compare ordered single precision floating point values. The unordered result is so what's the difference between unordered and ordered? And the signal's an invalid numeric. Okay, so I do want that. I do want it to throw an error when the thing is wrong. So there isn't an override that... Okay. Set greater, and is there a set M, like a set more? That's what I'm guessing. Set, so we have set less. Set less equal. Oh, it's above. Okay, so set A. So set above. This one would go right here. Set above, set greater. Set above equal. And then in the compiler, oh, this is... I'm gonna come up with a better way to describe this. Hopefully. You know what? You know what? Let's just pull an assembly language. We're gonna have above. Why do these need to... I don't understand why these need to be different instructions. I just... Because in my books, if something is greater than something else, it's also above something else. Okay, so here we also need to account for above. So set above. And we also have equal as set above equal. Why do those need to be separate? So now, in our AOT operation, compare node, it's not in the compare node. Can't use that anymore because we need to check if it's a... Is it signed or is it unsigned? The world may never know. Alright. So, if the sign is either of those things, then storage type is equal to if it's equal or not equal. In both these cases, we can just set it equal to this. However, if it's greater, we have to check. If it is signed, we use values storage type greater res. Otherwise, we use the value storage type above result. It makes so much sense. Here we use the greater equal res and the above equal res. It should work now. Have I added it to the script runtime? I have not. Set above. Set above equal. Because assembly language makes sense. So now, if we were to go into main, and we were to turn this back into a float, and this back into a float, right now it should return false and return true. Or 2. It does. Now if we swap it, it returns 1. Finally. Inner peace. On the bright side, I'm never gonna have to do that again. Or figure out how to understand that again. Why do floats use the things for unsigned even though they're like more signed than signed variables? I don't like it. I want to have a word with Intel and ask them, why do the jump conditions use the signed bit? I feel like that's like a couple bytes of instruction space that you could clear up for other commands. But you know, what do I know? I wonder, does ARM fix this? Conditional execution and branching. So we have equal, not equal, signed greater than, signed greater. ARM has the same thing. Why? Why is there always executed and never executed? Wouldn't that just be not writing the instruction? Or writing the instruction? Anyway, it is 1:30. I got my code working. I'm going to end this stream here. It work good. Pain. Let's actually see if we can return booleans. Just return condition. I'm feeling extra fancy today, so I'm actually going to write like a testing function. Just to show it off. This is bool. Oh, it worked on the first try. I like it. And that is where we're going to end the stream, with all the code actually working.